find some missing side lengths of a triangle in order for us to find our area for today. So with that being said, let's go ahead and dive into the area of regular polygons. So there's a lot of information here on this slide. I'm going to do my best to kind of explain everything kind of step by step. So we're looking at the area of a regular polygon today. The first thing we want to go over is what does it mean for a polygon to be regular? A regular polygon is a polygon with all sides and angles that are congruent. And we have the following formula right here to find the area of a regular polygon. In this formula, the capital A stands for the area. The lowercase a in red stands for something known as the apothem. The apothem is defined as the distance from the center to one of the sides. So I'm going to go ahead and draw in the apothem in this picture here. So this line right here would represent the apothem. So it's the distance from the center to one of the sides of the regular polygon. Now, one thing we want to make note of here is that your apothem is going to be perpendicular to one of the sides. So we'll see here that a 90-degree angle is formed. So that's your apothem. That's really the new vocabulary word that we're looking at in today's notes. And then the P in this formula stands for the perimeter. So the way we find the area of a regular polygon is we take 1/2 times the apothem times the perimeter. Okay. And we've got some additional variables that are going to be used throughout these problems, which we're going to take a look at here. If you ever see me use the letter S, please understand that S represents the length of one of the sides of the regular polygon. N represents the number of sides. Theta is going to be the angle formed by the radius and the apothem. So in this situation here, remember that the red line segment here is the apothem. Your theta is going to be formed by the radius and the apothem. So we can understand here that theta, let's do this here in pink, theta would be located right here. That's theta, right here, this angle. And that angle theta will be half of the central angle. While we're talking about central angle, the way you find the central angle of a regular polygon is by taking 360 and divided by n, which n, again, is the number of sides for that polygon. R in this situation is going to represent the length of the radius. We've looked at a radius before. It's very clear to see here in a circle, but we're not always going to have a circle in our pictures. In the context of regular polygons, please understand that your radius is going to be the length from the center to the vertex. So here's our center, this black dot. Your radius is from the center to one of the vertices of the regular polygon. So a lot of vocabulary to kind of sink in here, a lot of different variables that we're looking at. The main thing I want you to just focus on right now is the fact that we find the area of a regular polygon by taking 1/2 times the apothem times the perimeter. Okay. We'll look at the central angle later on in the notes. For right now, let's go ahead and just dive into some problems here. So as we start to look at some problems, we're going to start with some easier looking questions. This will be our level 1 questions. So for this first set of examples, we're asked to find the area of the following regular polygons, and they want us to round our answer to the nearest tenth. So that is one number after the decimal. So if you look at number 1, they're telling us that all 3 of these are regular polygons. So I can use the following formula that is up here at the top right of the screen. That will tell us the area of that regular polygon. Well, if this is a regular polygon, this is a regular quadrilateral, meaning that all sides are congruent. So with that being said, this is really just a square, right? 7 times 7 is going to tell us that the area is 49, but I want to show you how that works utilizing the new formula that we have here. So the formula that we're working with today is that the area of a regular polygon is 1/2 times the apothem times the perimeter. Well, let's take a look at the apothem. The apothem, we said, was from the center to one of the sides. That is your apothem. The perimeter, well, we need to find the perimeter. The perimeter can be found by adding up all the sides. If all the sides are 7, that'd be the same thing as multiplying 4 times 7, giving you a perimeter of 28. So we got the apothem, we got the perimeter. All we're going to do is just plug it in. And if we plug this in, what we end up with here is that the area is equal to 1/2 times the apothem, which is 3.5, times the perimeter, which is 28. Okay? And we have a calculator here just to make our lives easier. Let's go ahead and use it. So We're going to multiply this out. We got 1/2 times 3.5 times 28. So we got 1/2 times 3.5 times 28. If we multiply that out, you see that we get 49, right? So the same exact answer that we got earlier. So area is equal to 49, and I didn't put the units here on either one of these, so let's go ahead and take care of that now. We're looking at inches squared. So that is the formula of a regular polygon. You just take the apothem, 1/2, and multiply it by the apothem times the perimeter. Okay, let's look at another one here. Let's look at number 2. Number 2, we're working with the same idea that this is a regular polygon. And if we look here, this has 1, 2, 3, 4, 5, 6, 7, 8 sides. This is a regular octagon. So our formula to find the area of a regular polygon doesn't matter if it's an octagon, a pentagon, hexagon, doesn't matter. If it is a regular polygon, we can find the area by taking 1/2 apothem times perimeter. Well, your apothem is located right here. That is our apothem lowercase a. Your perimeter, well, we need to find the perimeter. They were nice enough to give us one of the side lengths here. So like we mentioned earlier, there are a total of 8 sides. So our perimeter can be found by taking 8 and multiplying it by 5.6, which at this point, I'm just going to type that into the calculator. We have 8 times 5.6. 8 times 5.6 gives us a perimeter of 44.8. So we now know the apothem. We know the perimeter. We have everything we need to find the area for this regular octagon. So if we plug this in, we're looking at the area is equal to 1/2 times the apothem, which is 6.76, times the perimeter, which would be the 44.8. Okay, let me just move this down because we're running out of space here. So we have times 44.8. And let me write this a little bit neater here. That is a 6.76, that apothem right there. Okay, so that's our area. We just have to multiply 1/2 times the apothem times the perimeter. So let's plug this into the calculator here. We have 1/2 times 6.76 times 44.8. Multiplying that out, we see that we get an area of, let's pull that back up, area of 151.424, but it asked us to round to the nearest tenth. So one number after the decimal. So this is approximately 151.4. So we got 151.4 for the area, approximately. And units are in inches squared. Okay, we got number 3 next. Let's take a look at number 3. If we take a look at number 3, I'm going to zoom in here just to make it a little easier for us to see. Maybe not. We already are zoomed in as much as we possibly can be. So let's take a look here. If we take a look at this particular problem, we're still working with the area of a regular polygon. So we are still working with the formula area is equal to 1/2 times the apothem times the perimeter. So here they give you the apothem. The apothem is the 6.5. We need to find the perimeter. The only issue here is that we don't know what the side length is. So we're going to find the side length here. So our focus here is going to be the following, and this is actually going to be a super important concept to wrap your head around here. So right now we currently have the apothem highlighted in yellow. This blue line right here represents the radius, okay? If I were to draw in another radius, what we basically create here is a isosceles triangle. Now, whenever we drop in an altitude, which this apothem represents an altitude for this triangle, what that does is that bisects the entire bottom side of this pentagon. So if we can manage to find x, this piece of our right triangle, then we know the whole thing would be x plus x, or basically doubling that amount. So our focus right now is going to be finding the value of x. So we have this following right triangle here. We have a right triangle with a side length of 6.5 for one leg. The hypotenuse is 8, and the bottom leg is x. So we can actually find x by using Pythagorean theorem. If we do Pythagorean theorem here, what we are looking at here is 6.5 squared plus x squared is equal to 8 squared. Now the 6.5 squared, I'm going to use the calculator for that. 6.5 squared is 42.25. So we have 42.25 plus x squared is equal to 64. Well, if we subtract 42.25, then we're getting closer to solving for x. So we're left with x squared is equal to, well, 64 minus 42.25 is 21.75. Okay. And then let me just double check to make sure that I'm not making any silly mistakes here. We have the 64 minus 42.25. It is 21.75. So if I want to solve for x here, I need to square root both sides. So let's go ahead and square root that. So we're going to take the square root of 21.75. So what you'll notice here is that that gives us approximately, so let me take that back. I'm sorry. So we typically don't want to round until the very end, right? So the more numbers we have after the decimal, the more accurate we're looking at here. So we have approximately 4.663689527. That decimal technically goes on forever. So you got two options here. You can leave x as the, technically what we did here is we took the square root of both sides. You can leave it as the square root of 21.75. Which that would honestly be our safer bet. Let's just do that. Okay, so x equals 21.75 underneath the square root. Okay, so that's the value of x. Now, if I want to find the perimeter is going to be us adding up all the sides here. Well, one of these sides is created by two x's. So basically, we're going to take that amount and multiply it by 2. So what we can represent one side length as is we can represent it as 2 multiplied by root 21.75. Okay, so that's one of the side lengths of the pentagon. So now we have enough information to find the perimeter. Okay, let me try to separate this out because this is getting a little bit messy. So the perimeter is going to be, we have a total of 1, 2, 3, 4, 5 sides. So this will be 5 sides multiplied by the length of one side, which is 2 root 21.75. Which this would be 5 times 2 is 10. So this is 10 root 21.75. Okay. And at this point, being completely honest here, if you feel more comfortable just putting this as a decimal, that's honestly fine. Okay. Just again, the more numbers you have after the decimal, the more accurate you are. And typically, I suggest holding off on rounding until the very end. So that's the perimeter that we have here. And so now we have everything we need to find the area of this regular polygon. Here's our perimeter. We're going to plug that in here for capital P. So if we're looking at our formula here, we have the area is equal to 1/2 of the apothem, which is 6.5. And I'm realizing I'm going to run out of space here. I'm going to just write it in here. So we have area is equal to 1/2 of 6.5 times our perimeter, which is 10 root 21.75. Okay, and so we're just going to multiply that out. If we plug this into our calculator here, we have, plugging this all in, let's type this in. We got 1/2 times 6.5 times 10 times root 21.75. So kind of a mouthful there, but when we multiply this all out, we get an area, and now we can round to the nearest tenth. Our area here, pulling that back up, rounded to the nearest tenth, is one number after the decimal. This 151.5 would round up to 151.6. So the area is approximately 151.6, and they don't give us any units here, so I'm just going to put units squared. So your area for number 3 is approximately 151.6 units squared. So we're running into the first instance where you're realizing that if they don't give you one of the side lengths, finding the perimeter becomes a lot more work than let's say, for example, number one or number two on this slide. Okay. But to summarize here, if you're looking for the area of a regular polygon, our formula is 1/2 times the apothem times the perimeter. And our apothem is the segment highlighted in yellow for each of these problems. Okay, so let's go ahead and keep moving. We're going to see now some slightly more challenging questions. And one thing that you're going to notice is that something that I just mentioned not too long ago is that when you're missing the side length, or if you're missing the apothem, sometimes you're even missing both of these, finding the area becomes increasingly difficult. For us to wrap our heads around the idea of what we're going to be doing here, we're going to have a series of questions on this next slide that we're going to go through. So let's go ahead and consider the following inscribed regular polygon. What it's asking us to do here is draw a radius connecting the center to a vertex of the polygon. So I'm going to mark the center here. And it's asking you to, well, draw a radius connecting the center to a vertex of the polygon. So let me actually do this like this. So that represents a radius. Okay. We're going to do that connecting the center to vertex of the polygon. And now it's asking us to actually do this for all of the vertices. So we're going to do that again here. We'll do it here for every single vertex. Okay, so I'll give you guys a second to draw that in. So what we did there in blue, we just drew in all the radii for this given figure, at least in the context of connecting it to each vertex. So now what we're going to take a look at here is, well, how many triangles are formed? Well, if we're looking at how many triangles are formed, we can count, pretty easily here that there's a total of 6 triangles. So total of 6 triangles. And what kind of triangles are they? Well, if we take a look here, right off the bat, we drew in radii, right? And we understand that all radii are congruent. So we technically just drew in a whole bunch of isosceles triangles. So they're isosceles triangles. And now it's asking us to find the measure of each central angle for each triangle that was formed. This part's going to be extremely important. The way that we find the measure of the central angle for these regular polygons has a formula, and that formula happens to be 360 divided by n, where n represents the number of sides. Well, let's take a look here. How many sides do we have here? 1, 2, 3, 4, 5, 6. We have a total of 6 sides. So this would be 360 divided by 6, which would give us 60 degrees for the measure of each central angle for each triangle that is formed. So essentially that tells us that it's 60, 60, 60, 60, and 60. So all of these triangles have a central angle measure of 60 degrees here. Okay, so now what it's asking us here is to draw a apothem. So draw an apothem in one of the triangles. So I'm going to just decide to draw it right here. If we draw in that apothem, remember that the apothem is perpendicular to the side. And one thing that we mentioned earlier is that these triangles are isosceles, right? That's what we mentioned right here. What kind of triangles are these? They're isosceles triangles because radii are congruent. Well, the second that I have an isosceles triangle and I drop it in an altitude, which in this case we're calling the apothem, if I drop this in, what's happening is that that altitude serves as a bisector, meaning that what's going to happen to the central angle? The central angle is going to be bisected. And so that's what we're going to write right here. What is happening to the central angle? Central angle is being bisected. And if that central angle is being bisected, we know that it's 60 degrees. So that means that this is going to be 30 degrees and this is going to be 30 degrees. And it's asking you what is happening to the side of that polygon. Well, I mentioned earlier that if it's an isosceles or equilateral triangle, when you drop in an altitude, it's a bisector. Not only is it bisecting this angle at the top, but it's also bisecting this side at the bottom. So what is happening to the side of the polygon? Also being bisected. And so the third question here becomes, what kind of triangle has been created now? Well, if we take a look at what we currently have here, what kind of triangle has been created? Looking at what I have highlighted here in green, The kind of triangle that we basically just made was a 30, 60, 90 special right triangle. So we really just made a 30, 60, 90. I'm going to put SRT, which is special right triangle for short. So now the question becomes here at the very end, this is the buildup, and this is ultimately what we're going to end up doing, is it's asking us if the apothem in this figure is 4 square root of 3, then what is the length of each side of the regular polygon? So let's work with this triangle that we have here. This triangle that we have here is a 30, 60, 90. And we see here that if they're asking us for each side of the regular polygon, and let me do this in a different color here. We essentially need to find this value of this bottom side of the green triangle. If I find that value, that's x, I know that it's going to be congruent to this piece here, making the length of one side of that, this is a hexagon, sorry, one side of this regular polygon, the regular hexagon, it's going to be 2x. So our focus right now is we want to find x. Well, if I want to find x, like we mentioned earlier, we said that we're looking at a 30, 60, 90. And we know currently right now that the problem says if the apothem in this figure is 4 root 3. This red line right here is your apothem. So we're understanding this to be 4 root 3. So if we're going to find the length of one side of the polygon, then we're going to work with finding the value of x, which if we're finding the value of x here, this is a 30, 60, 90. The hypotenuse is 2a. Across the 30 is a, and across the 60 is a square root of 3. Well, if our 4 square root of 3 is the a square root of 3 side, then it's going to be pretty clear to see here that a is just 4. If a is 4, then that tells us that the length of the bottom side of the triangle is 4. So going back up here, now we can actually figure out what this is. These pieces are congruent. So if this is 4 and this is 4, that would make the entire side, the length of one of those sides, 8. So what is the length of each side of the regular polygon? 8. Okay, so this is super important. There's really a lot going on here. The reason why I'm deciding to record a video is not only because I'm not there at school right now to go through this with you guys, but this gives you a video that you can rewatch in case you got confused or got lost somewhere along the way. But we're going to start looking at some problems here on the next slide. These problems are a lot more challenging. So do your best to kind of pay attention and keep up with what we're doing here in the notes. So what we're looking at now is these more challenging questions. And this part's extremely important if you want to highlight, underline, do something. But this is really important. When we draw in 2 radii and an apothem between the 2 radii. So in other words, let's actually draw this out so we can see what's going on here. If we draw in 2 radii, so this would be a radii, and this would be a radii. So if I draw in 2 radii and an apothem between the 2 radii, so here's your apothem, we can find the length of the apothem or the side length of the polygon. So that's really what it's asking you to do here. I'm going to just back that up so that doesn't cover anything up here. And we're going to try the following examples using what they're telling us to do here, highlighted in yellow. So it says find the area of the regular polygon. So if we are going to do what they asked, then let's go ahead and start off here. If we want to find the area of the regular polygon, let's kind of go ahead and just see what it is that we have to do here. Remember, the area of a regular polygon is 1/2 times the apothem times the perimeter. If I look at this picture, they tell you what the apothem is. The apothem is 7.24. So I have the apothem. The only problem that's preventing me to find the area is that we don't know the perimeter. We do know, though, if I have the length of one of these sides, then because this is a regular polygon, I can find my perimeter pretty easily. So our focus right now is going to be to find the perimeter. The only way we can do that is by finding the length of one of the sides. So we're going to repeat the process that we just did in the last slide that had us actually writing stuff down. So we're going to start off by drawing in 2 radii. So go ahead and draw in 2 radii. And I'm going to do these in blue. So here's 1 radii. It's another radii. And so, because this is getting kind of covered up here, I'm just going to go ahead and make a mental note here that this apothem is 7.24. Okay. So we drew in 2 radii. And Now, what we basically just created is a triangle. All right. And so we're going to focus our attention on this triangle. So we're basically going to be working with this triangle here. So in this triangle, what you'll notice here is that because I drew in two radii, I basically just created an isosceles triangle. Now I know this is isosceles, and that means that our apothem would be the altitude for this, creating a 90-degree angle. And if I have an altitude in an isosceles triangle, what it does is it bisects that bottom side. And it also bisects this angle here at the top. So our focus is going to be this. We first need to find the central angle. The central angle, remember that this is found by doing 360 divided by n, where n is the number of sides. If we look at this particular regular polygon here, we have 1, 2, 3, 4, 5, 6, 7, 8 sides. So our central angle here would be found by doing 360 divided by the number of sides, 8. And we can just type this into the calculator here. 360 divided by 8. Oops. See that again. 360 divided by 8. That gives us 45. So our central angle here is 45. So if we take a look here, let's go ahead and work with the triangle that we have here. I'm going to go ahead and draw that triangle off to the side because it's going to get really cluttered inside that picture. So we now know the central angle there. For that triangle right here, that central angle is going to be 45. However, what we're doing here is looking at this apothem here. This apothem, what it does is it bisects that angle of 45. And it bisects this bottom side here. So if this 45 is being bisected, that means it's being divided by 2. And if we bisect 45, it ends up being 22.5. So what we're working with right now is that we have 22.5 for this angle. The apothem here is labeled as 7.24. I'll just write this sideways here. And we need to use this given information to find the value of x. Because if I find x, this is also x. And when I add those together or double it, I now know the side of the polygon. So we are working now with, I'm going to separate out this triangle again just so it's easier to see. We're basically working with a right triangle, and we are trying to find the value of x. We know that this angle right here is 22.5. Let's try writing that a little neater. 22.5 for this angle, and we have 7.24. So the only way that we can solve for x here is, well, I can't do Pythagorean theorem. I can't do special right triangles. My only option here is to use trigonometry. So this is my angle of perspective, this is my opposite, and this is my adjacent. So what we're working with here is tangent. So we have tangent of the angle 22.5 is equal to, well, opposite over adjacent is x over 7.24. So we're going to solve for x here. Put this guy over 1 and cross multiply. That gives us x is equal to, well, 7.24 times tangent of 22.5. In this case, I know earlier I kind of left the answer as exact. We're just going to put this as a decimal just to make it look a little cleaner. So we're going to type this into our calculator. We're trying to see here what does 7.24 times tangent of 22.5 give us. So tangent of 22.5. We get approximately 2.998, which let's just round to the nearest hundredths. This is awfully close to 3. So let's just say, x is equal to 3 here. I know that we're rounding, we're slightly off, but we're just going to run with it here. So if x is 3, okay, that means that this is 3. And this is 3, right? Because right here, this is the bottom side of this right triangle, which the right triangle that we just separated right there is this one right here. Okay, so we see that that's 3, making the entire length of one side of this polygon be 6. So all of that work for us to just find the side of the polygon, right? But we could not move forward unless we found the side length. So now that we know the side length, our perimeter is going to be, well, this is a octagon, so there's a total of 8 sides. So 8 times 6 would give us a perimeter of 48. So plugging in what we currently know, we have the area is equal to 1/2 of the apothem, which was 7.24, times the perimeter, which we now know is 48. And now we just have to multiply that out and we have our area. So let's go ahead and type that in. We have 1/2 times 7.24 times the perimeter of 48, giving us an area of approximately 173 point, let's see that again, 173.76. So our area is approximately 173.76. And if we look at the units here, they have yards. So yards squared. Okay. So again, these problems are rough. They are difficult. They're not easy, but use the knowledge that you learned earlier this year, stuff like trigonometry, special right triangles to find the missing information that you need. That's the idea here. So let's go ahead and do a few more here. If we look at example 3, it says find the area of the regular polygon. Okay, well, this is obviously a square, right? You can use the formula for the area of a regular polygon, 1/2 apothem times perimeter. Let's go ahead and just practice this. So if we're going to use this, you'll notice here that in the formula, we are working with apothem and perimeter. I don't have either of those. So the general rule of thumb here is for these regular polygon problems, if you don't have the apothem or enough information to find the perimeter, you're going to start off by drawing in 2 radii. We already have 1 radius drawn in here, so draw in a second one right here, making this also 7. Now what you're going to do is draw in an apothem. Okay. Before you draw in that apothem, let's take a look first at seeing what would be the central angle for this. The central angle here would be, remember, that's 360 divided by the number of sides. So 360 divided by 4 tells us that the central angle here is 90. So this central angle is going to be 90 degrees. What we have to do now is draw in our apothem. If we draw in our apothem, what the apothem does, because this is an isosceles triangle every single time, the apothem is going to bisect that angle, making that 90 become 45 and 45. And so now we're working with a right triangle, and this happens to be a 45, 45, 90. So let's go ahead and take a look at what we have here. We have a 45, 45, 90 special right triangle. And if we take this out, then we're looking for 2 things here. We know that the hypotenuse is 7. We're essentially looking for this piece and this piece because this right here represents your apothem. That's our apothem. I need this bottom side here, and let's go ahead and just label it here for context. This would be x. This would be y. I need the x for the apothem in the formula. I need the y to find out the length of the entire side, which I'll move this down here. So we're going to use special right triangles. You could use trigonometry if you want, but honestly, special right triangles is going to be pretty easy to work with here. So if we're doing special right triangles, then this is a 45, 45, 90. We're working with the hypotenuse is your a square root of 2. Your legs are a and a. So here it's very clear that they gave us the a square root of 2 side. So a square root of 2 is equal to 7 here. If I want to solve for a, you're going to divide both sides by square root of 2. I'm purposely doing this because I want y'all comfortable with special right triangles. So a is equal to, well, I can't have a square root on the bottom. So the way we're going to fix this is we're going to rationalize. So multiply square root of 2 over square root of 2. Doing so is going to give you 7 root 2 over, well, square root of 2 times square root of 2 is square root of 4. Square root of 4 is just 2. So you can leave this as a fraction or as a decimal. 7 divided by 2, I'm just going to write this as a decimal. It is 3.5 square root of 2. So a is 3.5 square root of 2. So that tells us the value of x and y now. So now that we know the value of x and y, I can go to the picture here and just erase this. Erase this. We now understand that the apothem right here, this is 3.5 square root of 2. So I can start plugging in here. 1/2 times the apothem is, well, the apothem is 3.5 root 2. I just need to find the perimeter now, which this is 3.5 root 2 for the bottom side of this blue triangle. And remember that what the apothem does is the apothem not only bisects this angle, but it also bisects the bottom side of your polygon, making both of these 3.5 root 2. If both of these are 3.5 root 2, that would mean the entire side length here would be 3.5 root 2 plus 3.5 root 2 would give me 7 root 2. So now we can find the perimeter. The perimeter, we have four sides here, so it's 4 times 7 square root of 2, which if we multiply, we get 28 root 2. So that is our perimeter. So in our formula, that's your perimeter, so 28 root 2. And for these problems, what we can actually do here is, well, why don't we multiply this out? Okay. You can use a calculator. To be honest, one thing I would like for y'all to realize is when I multiply square root of 2 times square root of 2, it's going to give me square root of 4, which is just 2. But we'll let the calculator kind of carry the work here. So we have 1/2 times 3.5 root 2 times, oops, let's get out of that square root there. There we go. Times 28 root 2. And we get an area of 98. So the area is 98 on the dot, and we're looking at inches squared. Okay. So we will practice with one more. I know that there are two more examples, but we're getting to the point in the video where this is a really lengthy video, and I apologize. It's a really tough day of notes. So let's go ahead and keep it moving. We will do one more. Let's take a look at example 4 and example 5. Let's see which one will be slightly harder to do. Let's do example 5. Have we done a pentagon yet? Not for these. Let's do example 5. So it says find the area of a regular pentagon. So area of a regular pentagon, which has a perimeter of 100 inches. Well, the area of a regular polygon is found by taking 1/2 of the apothem times the perimeter. So we're going to draw a regular pentagon. Okay. So pentagon is 5 sides. So I'm going to draw our regular pentagon here. Let me do that a little bit thinner here. So here's our regular pentagon. Let's get this guy moved over here. And they tell you that it has a perimeter of 100 inches. So the good thing about us knowing that the perimeter is 100 inches, that tells us that we are only missing the apothem really right now. We know the perimeter is already 100 inches. Okay. Well, if the perimeter is 100 inches, we can use that information to find the length of each side, right? If this is a regular pentagon, regular polygons have all sides that are congruent. So, well, 100 divided by 5 sides would give me the length of one side. So the length of this bottom side is 20. Now, what we're missing right now is the apothem, right? So here is the center of our pentagon. To do this, we need to start by drawing 2 radii. So always start by drawing your 2 radii. Let me do this with some actually straight lines here. So here's one radius, here's another radius. And you're going to start by finding your central angle first. So if I want to find the central angle, remember that central angle is found by taking 360 divided by the number of sides. Well, we have a total of 5 sides here. So 360 divided by 5 tells us that the central angle is, what is this, 20, 40, 60, 72. So this central angle right here is 72 degrees. Now we're missing the apothem, so we are going to draw in an apothem here. Drawing in an apothem, remember that the apothem serves as a bisector to this isosceles triangle, meaning that this bottom side will be cut in half, making this 10 and 10. And not only that, the 72 has also been bisected, making that be 36 and 36. So remember that what we're missing currently is the apothem. So our goal right now is to find the length of the apothem. So we're going to be looking at the right triangle that we just created. So I'm highlighting this so that you can see what we're taking out of the picture here. So here's our right triangle. We know this bottom side is 10. We are looking for the apothem, which is this vertical side here. So we're going to call that X. And we have the angle of 36 degrees here. So we're going to use trig to help us out here because I can't do special right triangles. It's not a 30, 60, 90 or a 45, 45, 90. I can't do Pythagorean theorem because I only know one side. So trig is our only option. So if I'm doing trig, this is our opposite. This is our adjacent, telling us that we are working with TOA, which is tangent. So we're working with tangent of 36 is equal to, well, opposite over adjacent is 10 over x. Now, again, if you're wanting to play it safe here, put this guy over 1 and cross multiply. If we cross multiply, you're going to get 10 is equal to x times tangent of 36. Now, we want to solve for x here, which is the apothem. So we're going to divide both sides by tangent of 36. So that cancels, and now we have x by itself. X is equal to whatever 10 divided by tangent of 36 is. So that's where we take out the calculator. We're looking for 10 divided by tan 36. So 10 divided by tangent of 36. We are given 13.7638192. I'm actually going to be annoying and write out this entire decimal. Alternatively, you could also just plug in this for x. That is technically your apothem, right? Let's actually just do that, make our lives easier, right? If you want to put in the decimal value, that's totally fine. It boils down to personal preference. For me right now, I'm just going to plug in the 10 over tangent of 36 for my apothem because that's what we got for x, right? X here being our apothem. So we are looking at 10 over tan 36 for the apothem, and all we have to do now is just multiply this out. So if we multiply this out, we will have our area. This is going to end up being 1/2 times, let's put this in parentheses here, it's going to get a little messy, 10 over tangent of 36. Close my parentheses here, and then times the perimeter of 100. We end up with an area that is approximately, and we're just going to round to the nearest tenths again. I think that's what the instructions were earlier. 688.19 would round up to 688.2. So approximately 688.2, and our units here is inches, so inches squared. So that would be our area. Okay, so these problems are tough. You're only going to get better at these and more comfortable at these by practicing them. So I'd strongly encourage you to work on the homework. Now, kind of before this video ends, if you are watching this on Friday, March 21st, this is just a friendly reminder that on Tuesday, you guys will have your quiz over 11.1 through 11.4. And on Wednesday, you guys will have a mini quiz. And then on Thursday, you guys will have your DLA. It's a pretty loaded week next week. But if you guys have any questions or concerns, please just send me a message in Canvas and I'll do my best to get back to you guys. All right. You guys have a great weekend. I'll see y'all on Monday.